Today we are going to learn some derivative rules, and while we're not going to do too many proofs in this class, we are going to prove one or two of these rules just to show what a proof looks like. So let's start with the constant rule. And the constant rule is pretty simple. It just tells us that if f of x is equal to c, where c is a constant, c is in like the set of numbers like 1, 2, 0.5. It's anything that is constant, something like pi. Pi is a number. C, for example, doesn't have any variables attached. It's just one constant value. If we have f of x equals c, f prime of c, the derivative of c, is going to be equal to 0. The derivative of a constant is equal to 0. Another way to write this, d dx, the derivative with respect to x of c, is equal to 0. And our next rule is going to be the power rule. The power rule is going to be a rule that we use quite a bit when dealing with these problems. And the power rule states simply, let n be a positive number, positive integer, then if f of x equals x to the power of n, f prime of x, the derivative of x, is going to be n, we're going to bring that power down, x to the n minus 1. And let's see what this rule means in terms of actual functions. If I have something like f of x equals x to the 10th power, f prime of x is going to be equal to, well, in this case, 10 is n. So we're going to bring that 10 down to in front of x. And the power is n minus 1, or 10 minus 1, or 9. And that rule is going to be used quite a bit throughout the problems that we do. We also have some difference and constant multiple rules. We actually already saw these rules in place with the definition of the derivative, but let's look at the rule now. If I want to take d dx of a function f of x plus g of x plus, let's say, in fact, let's go back. Let's do f of x plus 2g of x minus h of x. Our derivative here would simply be the derivative of f of x is f prime of x plus the derivative of 2g of x is going to be 2g prime of x. Notice that that constant multiple just sticks around, minus h prime of x. Here we can think of a negative sign as like a negative 1 in front of h of x, so that's almost like the same thing as the constant multiple rule. And let's look at a proof of this one. This is a nice time to look at a proof. Let's do a proof of the sum rule. And the sum rule will work like this. I have some function j of x, which is equal to f of x plus g of x. Then j prime of x is going to be equal to f of x plus h plus g of x plus h minus f of x minus g of x all over h. This follows directly from our definition of the derivative, which is d dx of j of x. d dx of j of x is equal to j of x plus h minus j of x all over h. That's just coming directly from our rule. And up here, this is equal to f of x plus h minus f of x over h plus, we have the same denominator, so we can split it up as long as we keep our denominator, g of x plus h minus g of x, which is equal to, in end, f prime of x. This is exactly f prime of x by definition. If we look back up at our definition which is up here, definition, we get exactly f prime of x plus g prime of x. And that is our definition of the derivative, so that's our definition of the sum of derivatives. And so these rules already allow us to look at the derivative of a lot of functions. Let's look at f of x equals 2x to the 5th plus 7. So if I'm looking for f prime of x, in our first term here, we bring this down. We have our constant multiple, so the 2 sticks around, and we get 5x to the 4th. And then our constant rule for the derivative of 7 is just going to be 0. Remember, that's the first rule in this video. And so in the end, our derivative is 2 times 5 is 10x to the 4th power. Similarly, let's take another example. Let's say this is example 1. Let's do example 2. Example 2 is going to be f of x equals 2x to the 3rd power minus 6x squared plus 3. And if I take the derivative of that, you can pause the video and try it yourself. F prime of x is going to be the first piece here, the 3 comes down, 2 times 3 is 6, x to the 3 minus 1 is 2. The second piece, we're going to have 6 times 2 is 12, x to the 2 minus 1 is 1, x to the 1st power. And then we have another constant here, the derivative of which is 0. So in the end, we get 6x squared minus 12x plus nothing. Awesome. And let's remember exactly what these questions are asking. So if I want to find the equation, this is going to be example 3. If I want to find the equation of the line tangent, the line that touches a function at exactly 1 point, to f of x equals x squared minus 4x plus 6 at x equals 1, I can use the derivative to help, because remember, the tangent line is going to have the exact same slope as the function at that point. So we just need to find the slope of the function at that point, and the derivative tells us the slope. So first I can say f prime of x is equal to 2x minus 4. That's our rule on the first term, our rule on the second term. The third term just goes away. Which means at x equals 1, we have a line with slope. What's that slope going to be? The slope is going to be exactly f prime of 1, which is equal to 2 times 1 minus 4, which is equal to negative 2. So now we have a slope. We have m equals negative 2. We have an x value. We have x equals 1. We could get a y value because we know that we're touching this function at this point. So the y values should agree. So let's do that real quick. Let's find f of 1, which is going to be 1 squared minus 4 times 1 plus 6. And so f of 1 is going to be equal to 1 minus 4 plus 6, which is equal to negative 3 plus 6 is 3. So now we have m equals 2, x equals 1, y equals 3. We know that the equation of a line is y equals mx plus b. We have one equation with 4 variables, 3 unknowns. We can plug our three variables in, the 3 things that we know. So this is 3 equals negative 2 times 1 plus b, which gives me 3 equals negative 2 plus b. And so if I add 2 to the other side, I get 5 equals b. So going back, we have the question, what is the equation of the line tangent to that function at x equals 1? The equation of the line is exactly y equals m, negative 2, x plus b, plus 5. And so that's the answer we get. And so with our constant rule, our sum rule, let's go back and look at all of our rules. We have the constant rule. The derivative of a constant is 0. We have the power rule, which is simply the derivative of x to the n is nx to the n minus 1. And then we have our sum, different, and constant multiple rules, which tell us how to deal with things that have a constant in front and how to deal with sums and differences. With all of that, we can take the derivative of just about any polynomial and start answering questions about their graphs.